right, this is going to be objective 10. We are going to finish labeling the unit circle. We started on this on Friday. I'm going to repeat it because sometimes it doesn't quite sink in the first time I talk about it. So, and if you left early on Friday, you missed this part. This is what we did at the end of class. So, we started talking about, in geometry, you learned special relationships between 45, 45, 90 triangles and 30, 60, 90 triangles. Okay? We learned in a 45, 45 triangle that the hypotenuse is the leg times the square root of 2. Okay? If we go to our unit circle, and we know that this is 0, correct? And if I go to a 45-degree angle, so this would be 45, if I can figure out, if I'm plotting it, and I go across X amount, units, and I go up Y units, and that would make a coordinate point on the unit circle, X comma Y. What do we know? This is going to make a right angle, so this would be your hypotenuse. What is our the amount of our hypotenuse? How much in the unit circle? It's 1 because it is a radius, correct? Everybody agree it's a radius? So if our hypotenuse is equal to 1, the question is, what would the legs be? So if we took this, we know the hypotenuse is equal to the leg times the square root of 2, correct? And we know the hypotenuse is equal to 1 in the unit circle. My question is, what would the leg be? What would you do to solve this? If this is being times by the square root of 2, you would divide by the square root of 2. And then the leg is going to equal 1 over the square root of 2, except there's a problem with that. What's the problem? You can't have a square root in the denominator, so you need to rationalize. So when I rationalize that, that's our leg is going to be equal to the square root of 2 over 2. Everybody with me on that? And you can't simplify those. Why not? Because one's on the inside of the radical, one's on the outside. So we know that this leg is going to be, if the hypotenuse is 1, then the leg is going to be the square root of 2 over 2. And what's this leg going to be? Square root of 2 over 2. Does that make sense? It's going to be the same thing, because if the angles are both 45, then the legs are obviously going to be the same thing. Okay? So if we go to our unit circle, okay, this is what you have today. Okay? I want to start by reviewing what we did on Friday. This is broken down just by the 45s. Okay? I've taken the 30 and 60 degrees out of the circle. So, first of all, let's start here on the right with what degrees? 0 degrees. Then we went up to 90 degrees. Then we went to 180 degrees. Then we went to 270 degrees. Okay? Then right beside of it, we did it in terms of radians. So when I'm talking about degrees, you with me? I'm talking about like the angle, and it's opening up. When I'm talking about radians, I'm just more specifically talking about the arc that subtends the angle, but it's still the same angle, right? So one is basically in terms of degrees, and one is in terms of radians. Okay, does that make sense? One's in terms of the angle, and one's in terms of the arc of the angle. Okay, but they're the same thing. So this would be 0 radians at this point. We're completely closed. And then we open it up. Now, we said a minute ago, how much was that 180? Pi. Everybody agree? Because there are 3.14, 3.1415, whatever pi is, radii that makes that arc. So if I chopped this in half, you would say that this would be what? Half of pi or pi over 2. Okay? And if you talked about it in terms of 90 degrees, so this is 1 pi over 2, right? Another 90 degrees would be 2 pi's over 2, right? And 2 pi's over 2 is just pi. And then if you did another 90 degrees, that would be 3 pi's over 2. And then you do another 90 degrees and you get 4 pi's over 2. But what is 4 pi over 2? 2 pi. Okay? And 2 pi is the same as 360 degrees. One complete rotation. Okay? And then we talked about the points. Okay? So if this were like a coordinate plane, this would be 0, 0. So over here would be 1, 0. Up top would be 0, 1. To the left would be negative 1, 0. And going down would be 0, negative 1. Any questions on what we did the other day? That's as far as we got the other day. Okay, so now let's talk about our 45 degrees. Okay, so let's do the degrees first. This would be 45 degrees. Another 45 would be 90. Another 45 would be 135 degrees. Another 45 would be 180. Then another 45 would be 225. Then another 45 would be 270. Then another 45 would be 315. And then the last 45 would be 360. Okay, any questions? We're counting by 45s. No, don't go to the full, because we're going to come back and apply what we learned here when we're done with this to the unit circle. Okay, so just do this one. Just do the one I gave you today. Okay, so we'll work on the big unit circle that I gave you the other day in a few minutes. Okay. All right, let's go to radians. Okay, so we know that 90 degrees is pi over 2. And 45 degrees is half of that, correct? So if I took half of pi over 2, what would that be? Pi over 4. Okay? And so what we're going to do, a minute ago in degrees, think how we just counted out the degrees. The degrees are easy, right? Because we did 45, that's 1 45. This would be 2 45s. This would be 3 45s, correct? This would be 4 45s. And that's how we got our degrees all the way around. We just kept adding 45, okay? So this is 1 pi over 4. Everybody agree? This would be 2 pi's over 4. 2 45s. 2 pi's over 4. 2 pi's over 4, do you understand what I'm saying here? 2 pi's over 4, that would reduce to what? Pi over 2. Okay? This would be what? 3 pi's over 4. And then if we went again, this would be 4 pi's over 4, which reduces to pi. You with me on how I'm counting this? Okay, this would be 5 pi's over 4. This would be 6 pi's over 4, and that reduces to what? 3 over 2. Okay, 3 pi's over 2. This would be 7 pi's over 4. And then finally we would have 8 pi's over 4, which would be 2 pi. Do you understand? If you will get in the habit, when we do the unit circle, of counting, like if we're counting by 30s, we're counting by the smallest angle that we're counting by. So we're going to count 1/30s, 2/30s, which would be 60, 3/30s, which would be 90, all the way around. It's going to help you count those fractions. Okay? And if you'll do that every time we count, it'll get better. Sooner than later, I know today it's kind of probably iffy, but it'll get easier to count it that way. Okay? All right, so let's talk about what the coordinates are. So a minute ago, we talked about our 45. So if we know this is 45 and this is a 90, what's this up here? 45. And we know this is a radius, correct? And a radius is worth 1. So what's this amount? What's the x? We did it 2 seconds ago. It was the square root of 2 over 2. Okay, and one leg is going to be the same as the other leg, so what's the y going to be? Positive square root of 2 over 2. No, why are these still going to be positive? Because we're in quadrant 1. Positive, positive. Okay, let's go ahead and throw our signs in here. So over here, what would my signs be? Negative, positive, and then negative, negative, then positive, negative. Okay. All right, so let's talk about this one over here, because it's going to be the same thing. It's still a 45-degree angle, is it not, from the origin? So this is still going to be a 45-degree angle up here, and it's going to have a right angle there, and this is still going to be a hypotenuse of 1, correct? So what will the legs be? They're still going to be square root of 2 over 2 and square root of 2 over 2, except because we're in quadrant 2, it's going to be, the x is going to be negative square root of 2 over 2, and then positive square root of 2 over 2. If I go down and I look at this angle, this is still 45 degrees, okay, from the x-axis. So this would still be 45 degrees. This would still be a right angle. This would still be a hypotenuse of 1, which means the legs are still going to be square root of 2 over 2 and square root of 2 over 2, except what? They're both going to be negative. Square root of 2 over 2 and negative square root of 2 over 2. Okay? So what do you think the last one's going to be? Square root of 2 over 2 and negative square root of 2 over 2. Any questions? Did I lose anybody on why it's square root of 2 over 2 and why they're both the same? Because they're both legs of a 45-45 triangle. Why the signs are the way they are? Because they're in the quadrants. Okay, so I'm going to pause the video really quickly. What I would like for you to do is I want you to go to your large unit circle. See if I can go to that one. Yep. And I want you to pick a color. And let me fill in what you did the other day first, real quick. So you did 0, 0, 360, 2 pi. This was 90 and pi over 2. This was 180 and pi. This was 270 and 3 pi over 2. And this was 1, 0, 0, 1, negative 1, 0, and 0, negative 1. Okay, so I want you to pick one of your colors. So I'm going to choose red, and I want to highlight, you need one of those. Okay. I want you to highlight the 45-degree angles. So what's the first angle we see? A 30. Okay, so the 45-degree angle that you should be highlighting with your color. There you go. Anybody else need one? Everybody got one? Okay. The 45-degree angle should be the middle one in each of the quadrants. Okay, the first one's your 30, the second one's your 45, the third one is your 60. Okay, so I'm going to take my red and I'm going to highlight the 45s. And I want you to go ahead and fill them in. So here's what I'll tell you. As far as memorizing this, I mean, you need to know your degrees all the way around. So this will be 45. This will be 135. This one is 225. And this one is 315. And then you need to know your radians. This is going to be 1 pi over 4, not 2. This should be 4. 2 pi's over 4, 3 pi's over 4, 4 pi's over 4, 5 pi's over 4, 6 pi over 4, 7 pi's over 4, and then 8 pi's over 4. Okay, I highly recommend that's how you count it around. That's going to help you fill it in. But if you know the first quadrant, square root of 2 over 2, and square root of 2 over 2, then you can figure these out over here. Negative square root of 2 over 2, and square root of 2 over 2, and then negative square root of 2 over 2, and negative square root of 2 over 2, and then square root of 2 over 2, and negative square root of 2 over 2. Okay? Any questions on what we've done so far? Do I need to give you a minute? Okay.
When you did in the notes, it showed the legs, like you got how podcast you could make this Times Square to get the square root 2 over 2. Like, square root 2. How'd you do that?
Okay. So now we're going to take a look at 30, 60, 90 triangles. And I'm going to give you this page. This one has taken out all the 45s. So when I give this to you, I want you to take a minute and go ahead and label your 0, 90, 180. Go ahead and label each axis. So yours looks slightly different than mine. I could not get a good picture of the one that you have. Mine still has the 45 in it, but I'm just going to kind of ignore it. Okay? So we're just going to work off the 30 and the 60. So we're going to go ahead and label 0, 0, 90, 180, 270. What are my radians? 0, pi over 2, pi, 3 pi's over 2, okay, and then 2 pi, and 360 degrees, okay? And we can label the points here if you'd like to. So this would be 1, 0, this would be 0, up 1, this would be negative 1, 0, this would be 0, negative 1. Okay? All right, so let's talk about the 30. First thing I want you to do is let's label the degrees. Okay, so let's count by 30s. We're going to count by the smallest one we start with, okay? So we have 30 degrees, then we have 2 30s, which would be 60 degrees. Then we have 3 30s, which is 90. 4 30s, which is 120. 5 30s, which is 150. 6 30s, which is 180. 7 30s, which is 210. 8 30s, which is 240. 9 30s, which is 270. 10 30s, which is 300. And then 11 30s, which is 330. And then 12 30s would be 360. Do you understand? I know you don't need to count degrees by that, but I think if I count the degrees by that, then it'll make the radians simpler, okay? So, with the radians, I'm trying to think the best way to explain it to you. So, if you know this is pi over 2, correct, at 90 degrees, 30 is how much of 90? A third. So what's a third of pi over 2? What's a third times pi over 2? 1/3 times pi over 2, which would be pi over 6, okay? So this one's pi over 6, okay? So that's how we're going to count it. We're going to count this as 1 pi over 6. 60 would be 2 pi's over 6, but what is 2 pi over 6 reduced to? Pi over 3. You with me? 90 would be 3 pi's over 6, which is a half. 120 would be 4 pi's over 6, which would be 2 pi over 3. 150 would be 5 pi's over 6. And then pi would be 6 pi over 6, which makes pi. Okay, so what's 210? 7 pi's over 6. Then 8 pi's over 6, which reduces to 4 pi over 3. Then 9 pi's over 6, which is 3 over 2. Then 10 pi's over 6, which reduces to 5 pi over 3. And then 11 pi's over 6. Okay, any questions on how to count it? Count it by, like I'm telling you, when you have the quiz, like take it in sections, okay? When you have your 3 chances to get this filled out completely correct, like count it, 1 pi's over 6, 2 pi's over 6, 3 pi's over 6, 4 pi, if you count it all the way around and reduce it as you go, then it'll be a lot easier and you won't miss your radians, okay? All right, let's go figure out what the coordinates are of this. So I want to go back. We talked about this the other day. So in geometry, you learned a 30, 60, 90 relationship between the sides and the angles. So you know that the shortest side is equal to A, side opposite from the 30-degree angle. You learned that the hypotenuse was 2 times the length of the shortest side. Okay? And you learned that the longer side would be the shorter side times the square root of 3. Okay, that was the relationship. So if I drew this, see if I can draw it bigger, as a, let's do a 30-degree angle. Okay, and I want to figure out the x and the y.
in the old gym a few minutes ago. I got really sad, so I was like, I gotta go see this corn stuff. I'm sad now.
Oh, good times. Goodbye. All right. So, this is a right angle. What would this angle up top be? 60 degrees. Okay. What's the measure of the hypotenuse? 1. Okay, so now let's think about this. We know that this hypotenuse, if it's a unit circle, that this is going to be equal to 1. Correct? So, how can I figure out what A would be? We could divide both sides by 2, and we know that A is going to equal a half. Correct? So I know this shortest side down here is going to be equal to a half. If I know that the longer side is A times the square root of 3, then it would be a half times the square root of 3, which would be the square root of 3 over 2. Do you understand that? So one side's going to be, this side right here is going to be equal to 1 because it's the hypotenuse. The shorter side opposite from the 30-degree angle. So if I'm looking at my 30-degree angle, that's going to be the y. The side opposite from it is going to be equal to what? 1/2. And then the side opposite from the 60-degree angle is going to be equal to the square root of 3 over 2. Do you understand that? So, y is going to be a half. So if I go to this over here, and I made this into, this is your 30-degree angle. Okay, same thing here. So this is 60, this is 30, this is 60. This is going to be equal to, so if I want a coordinate point, the side opposite from the 30 is going to be a half, and then the side opposite from the 60 is going to be square root of 3 over 2. So if I listed this as x comma y, it would be what? Square root of 3 over 2 comma 1/2. Okay, so let's look at the 60-degree angle. Okay, let's see if I can erase so it don't confuse you so much. It is. I'm trying not to confuse you the best I can. So if I looked at the 60-degree angle, so this is 60 degrees. This one's going to be 30 up top. So tell me what the one at the bottom is going to be. If I made this into a triangle. This one's 1. This is going to be 1/2 down here, and the side opposite from the 60 is going to be square root of 3 over 2. So if I go up here and write the coordinate, it would be 1/2 and then square root of 3 over 2. They're just going to be the opposite. Because one's going to be 30, 60, 90. One's going to be 60, 30, 90. Okay, they're just going to be opposite. Okay, so if I go over to this side, let me just do the 30-degree angles first, so you know which ones are which. Okay, so I'm going to do the 30. You don't have to do this in a color unless you want to. I'm going to have you do the color on the main one. Does that make sense? But if you want to do the colors on here, you can if that helps you. So this is a 30-degree angle. So this one is your 30-degree angle over here. And if you extended this out, this would be your 30-degree. And if you extended this one out, this would be your 30-degree. Okay? It's 30 degrees from the x-axis. Does that make sense? So 30 degrees here, 30 degrees there, 30 degrees from your x-axis. Okay? So using this, you know it's going to be the same, correct? Yes? Just going to be different quadrants. So over on the 150 side, what would the coordinates be? If we know on the quadrant 1 side, it's square root of 3 over 2 comma 1/2, over here it would be negative square root of 3 over 2 and positive 1/2. Okay? Down at the 210, it's going to be negative square root of 3 over 2 and negative 1/2. Okay? On this side, it's going to be, at 330, it's going to be positive square root of 3 over 2 and negative 1/2. Okay? If I did my 60 degrees, let's do them in purple. So there's your 60 degrees. If you extend this line all the way down, there's your 60 degrees. That's your 60 degrees. And that's your 60 degrees. And when I say 60 degrees, I mean that it's 60 degrees to the x-axis. It is 60 degrees to the x-axis. It is 60 degrees to the x-axis. It is 60 degrees to the x-axis. You follow me on that? Okay. So we know at 60 degrees, it's going to be positive 1/2 and positive square root of 3 over 2. So let's go over to the 120. Okay. So that's going to be what? Negative 1/2 and square root of 3 over 2. Okay. Down here at 240, it is negative 1/2 and negative square root of 3 over 2. Okay, and then right here at 300, it is positive 1/2 and negative square root of 3 over 2. Okay, so we're almost finished. We just got to put it all together. All right, so what I need you to do is I want you to go back to your original. And we're going to take some time and we're going to fill it all in. Okay, so let's start with, let's mark your 30 degrees. In one color. Okay, and this is going to be 30 degrees. 2 30s would be 60, but I'm not going to do that yet because that's going to be in a different color. And then 90, then, well, that's going to be a different color, sorry. 120, then 150, then 180, then 210, then 240, then 270, then 300, then 330. Okay, and then our radians are going to start with pi over 6. This will be 1 pi over 6. This would be 2 pi's over 6, 3 pi's over 6, 4 pi over 6. This will be 5 pi's over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi's over 6. Okay. And then you can fill in, what will the coordinates be for the 30s? Square root of 3 over 2 and 1/2. And then on the other side, it'll be negative square root of 3 over 2 and 1/2. This will be negative square root of 3 over 2 and negative 1/2. This will be square root of 3 over 2 and negative 1/2. Then I'm going to take a different color. I'm going to choose, I think I'm going to go with green. And I'm going to do my 60s. Maybe it just got overheated since it's working again. All right, so this is 30, This will be 60. This will be 90. This will be 120, 150, 180, 210, 240. This is 300. Now, I do want to show you, if you wanted to, like, you can count the 30s. 1 pi over 6, 2 pi's over 6, 3 pi's over 6. But you could count by 60s too. Does that make sense? 60 is 2/3 of 90. So this is going to end up being pi over 3. So this will be 1 pi over 3. This would be 2 pi's over 3. This would be 3 pi's over 3 would be 180. That's another 60. This would be 4 pi's over 3. This would be 5 pi's over 3. And that could be 6 pi's over 3. So you could count it by 60s instead of by 30s if you wanted to. And then you know your quadrants or your coordinates are going to be 1/2 and square root of 3 over 2. So this is negative 1/2 and square root of 3 over 2. Down here is going to be negative 1/2 and negative square root of 3 over 2. And then on this side is going to be 1/2 and negative square root of 3 over 2. And then we have it all filled in.